the research challenges we're currently focusing on is, although we developed a good antiviral for hepatitis B, there have been, and others have come along, second generation antivirals for hepatitis B, there is still a problem that has been a major challenge in hepatitis B, is that you have to stay on the medications, and we don't cure people very often. Most times the patients have to continue to take the medication to keep the virus suppressed. That's because the hepatitis B virus has made a tiny copy of itself that gets into the nucleus of liver cells, and that tiny copy is hard to get rid of. So we're focusing on ways that we might be able to rid the cell, the liver cell, of this tiny copy of DNA that would allow us to cure many more people that have chronic hepatitis B. The other challenge that we've taken on in the lab in a very major way is working with hepatitis C. And hepatitis C has been a big challenge because there is no cell culture system and there was no animal model. And we have worked on developing an animal model for hepatitis C. I have done this work with Dr. Norm Kniedemann, a transplant surgeon here at the University of Alberta, and his graduate student, Dr. David Mercer, who was a surgery resident who did a PhD with us. And we developed a way to take a mouse and humanize the liver of a mouse. These mice are what we call skid beige mice. They don't have a strong immune system. They're like the bubble babies. And you can put a skin graft from human onto that mouse and they don't reject it. So we knew that if we could find a way, that there might be a way we could put human liver cells into this mouse and humanize the liver of the mouse. The second thing we did is we put a gene in that is expressed shortly after birth that destroys the mouse's own liver cells, and we rescue them with human liver cells. So by the time the mouse is 8 to 12 weeks old, 70 to 80% of its liver is human liver. And this animal can be infected with hepatitis C. And this is the only animal model in the world, other than a chimpanzee or a human, that can be infected with hepatitis C. So it's become an extremely valuable model for the study of this disease. And it's an indication of that is the National Institutes of Health in the United States currently has one contract to study antiviral agents for hepatitis B in an animal model, and that's held here at the University of Alberta by a small company that we spun off called KMT Hepatech. So I have enjoyed my academic life, but I've seen opportunities where you can translate some of these findings into spin-off companies and see the application. I really feel I'm privileged to have been a clinician who has some understanding of basic sciences, but can play a role in translating discoveries from basic sciences into practical applications for the use against viral hepatitis is my major interest, both hepatitis B and hepatitis C. And with that animal model, we're now we're testing a lot of compounds to see if we can get efficient compounds to inhibit hepatitis C better than our current therapy.